today we are going to discuss some practical problem. So first of all, discuss some important formula. So first formula, n of A union B. So n of A union B is equal to n of A plus n of B minus n of A intersection B. Second formula, suppose here two set is present, set A and set B, but suppose three set is present, A, B and C. So how can we represent the formula? So n of A union B union C is equal to n of A plus n of B plus n of C. That means all these element n of A plus n, all this set n of A plus n of B plus n of C minus intersection of first two set, that means n of A intersection B minus n of B intersection C, that means second and third set minus n of C intersection A and plus n of A intersection B intersection C. So three set is present, three term is present. So at that time using by this formula, and only two term is present. So using by first formula. Now next one, n of A minus B, otherwise n of A difference B, so is equal to, we can written using by the formula n of A difference n of A intersection B. Fourth formula, n of B difference A. See here first position is A is present, so we can return n of A difference n of A intersection B. But here first position is here B is present and after A is present. So similarly we can return n of A in place of, we can return here n of B difference n of A intersection B. Next, n of A dash union B dash. So n of A union B dash is equal to n of U difference n of A intersection B. And last formula, n of, similar formula here, A dash union B dash form is present, so n of U universal set U minus n of A intersection B, and n of A dash universal set U in place of intersection form is present, so n of A dash intersection B dash is equal to n of U universal set U difference n of, here intersection form is present, so here we can return n of A union B. Okay, so now related to all this formula, now solve some example. So first of all, discuss exercise 1.6 question number 1. First question, if x and y are two sets such that n of x is equal to 17, n of y is equal to 23, and n of x union y is equal to 38. Our question is find out n of x intersection y. So here two sets is present, set x and set y, and two sets is present. So here using by first formula, n of a union b is equal to n of a plus n of b minus n of a intersection b. So here data is given. First of all, we can written here n of x is equal to 17 is given, n of y is equal to 23 is given, n of x union y is equal to 38 is given, and our question is find out n of x intersection y. So we know that n of x union y is equal to n of x plus n of y minus n of x intersection y. Therefore, n of x union y in place of written here 38 is equal to n of x, value of n of x is given here 17, so written here 17, plus n of y in place of written here 23, minus our question is n of x intersection y. So this data is not given. So first of all add this number. So 38 is equal to 17 plus 23, that means 4040, minus n of x intersection y. Now this negative term written in opposite side, here minus sign is present, so we can change the sign, and 38 positive sign is present, so written in opposite side and change the sign, so here we can written minus sign. So therefore n of x intersection y is equal to 40 minus 38, so is equal to 2. So here we get n of x intersection y is equal to 2. Now one more example, question number 2. Next question. Question number 2. If x and y are two sets such that x union y has 18, x has 8, elements, and y has 15 elements. Our question is how many elements does x intersection y have? So again here two sets is present, x and y. So again same formula here apply. First of all, here data is present. Which data is present? So x has 8 elements. So first of all, we can return here n of x is equal to 8. Second data is given y has 15 elements. So n of y is equal to 15, and x union y has 18 elements. So n of x union y is equal to 18. Now our question is find out how many elements does x intersection y. So n of x intersection y find out here. So again same method, we know that n of x union y is equal to n of x plus n of y minus n of x intersection y. N of x union y value is given 18, so here written 18 is equal to n of x in place of written 8 plus n of y in place of written 15 minus n of x intersection y. Again same method, this negative term written in opposite side, so change the sign. So n of x intersection y is equal to 15 plus 8, that means 23, minus here 18 is present in plus sign. Now 18 written in opposite sign, so change the sign. So minus 18, so is equal to 23 minus 18 means 5. So therefore n of x intersection y is equal to, we get 5. Now next one. Example 23, similar method here apply. If here question is present, if x and y are two sets such that x union y has 50 elements, x has 28 elements, y has 32 elements, and our question is how many elements does x intersection y have. So again here same method apply. First of all, here x has 28 element is present, so we can return n of x is equal to 28. Y has 32 elements is present, so n of y is equal to 32, and x union y has 50 element is present, so n of x union y is equal to 50. Now our question is how many element does x intersection y. So find out n of x intersection y. Now again same method, same formula apply here. First of all, we know that here two sets is present, so again same formula, n of x union y is equal to n of x plus n of y minus n of x intersection y. N of x union y in place of written here 50 is equal to n of x in place of written 28 plus n of y in place of written 32 minus n of x intersection y, find out here. So therefore n of x intersection y written in opposite side and change the sign. Now 28 plus 32, that means 60, and 50 written in opposite side, so change the sign 50. So therefore n of x intersection y is equal to, here we get 10. Now after example number 24. Now here data is present. In a school there are 20 teachers is given who teach mathematics or physics. Of these, 12 teach mathematics, 4 teach both mathematics and physics and mathematics. How many teach physics? So first of all, here we can consider let M denotes the teacher teach mathematics and P denotes the teacher teach physics. Now here 12 teacher teach mathematics, that means here we can written n of m is equal to 12. 4 teacher teach physics and mathematics, so n of m both, that means intersection. So 4 teacher teach both physics and mathematics, so n of m intersection p is equal to 4. And in a school there are 20 teachers who teach mathematics or physics, that means n of m union p is equal to 20. Now how many teachers teach physics? That means find out n of p. So again same formula here apply. First of all, we know that n of m union p is equal to n of m plus n of p minus n of m intersection p. N of m union p in place of written 20, n of m in place of written 12 plus n of p we can find out here, and minus n of m intersection p, that means 4. So therefore 20 is equal to 12 minus 4 means 8 plus n of p. Now 8 written in opposite side, so 20 minus 8 is equal to n of p. So therefore n of p is equal to 20 minus 8, that means 12. So our answer is n of p is equal to 12. N of m is equal to 12 is given, n of p is equal to also 12 is given, and 4 teacher common in both these subjects. So m intersection p is equal to 4. So our answer is n of p is equal to 12. Now in exercise 1.6, question number 3 is present. In question number 3, in a group of 400 people, 250 can speak Hindi and 200 can speak English. How many people can speak both Hindi and English? So first of all, here we can consider, let H be the set of people speaking Hindi. E be the set of people speaking English. Now, here data is present, 250 can speak Hindi. So, N of H is equal to, here given 250. 200 can speak English. So, N of E is equal to 200. And in a group of 400 people is present, so N of H union E is equal to 400. So our question is, how many people can speak both Hindi and English? That means find out N of H intersection E. So again same formula apply here. First of all we can written, we know that N of H union E is equal to N of H plus N of E minus N of H intersection E. Now again data is present here. N of H union E, the value is given 400, so here written 400 is equal to N of H in place of written 250 plus N of E in place of written 200 minus N of H intersection E, find out. Therefore, 400 is equal to 250 plus 200, that means 450 minus N of H intersection E. Now, N of H intersection E, negative sign is present, so written in opposite side, and 400 written in this side. That means interchange the position of both these terms and change the sign. So N of H intersection E is equal to 450 minus 400. So therefore N of H intersection E is equal to 450 minus 400 means 50. So our answer is N of H intersection E is equal to 50. So once again, in this question, in a group of 400 people is present, and people both type of people is present. People can speak Hindi and people can speak English. So Hindi people, we can say that denoted by capital H, and people speak English, so we can denote it by capital E. Now here data is present, 250 people can speak Hindi, so here we can written N of H is equal to 250, and 200 people can speak English, so N of E is equal to 200. Now again total number of people is present 400, so we can written here N of H union E is equal to 400, and how many people can speak both Hindi and English? So we can represent it, means find out n of H intersection E. Here using by both these words, that means here intersection we can consider. So n of H intersection E is equal to find out. Now after we know that this formula and substitute the value of this result, so we get the value of n of H intersection E is equal to 50.